Okay. So a paper co-authored with Maros Sabatka and Radovan Vadovic. And here we want to focus on something that this vast literature on social preferences has essentially ignored. And that is the distinction between acts of commission and acts of omission. An act of omission and an act of commission can only be defined relative to the status quo ante in which an action is taken. And I think that a lot of what's being talked about in these wonderful talks about how to change charitable drives are actually changing, are attempting to change what is perceived as the status quo ante and what is an act of omission versus commission. So I think, although our approach to this has been laboratory experiments and a purely approach closely tied to development of theory, I think that this has a lot of applications in what we're doing here. Now, one of the things we just know from life is that the intensity of reactions often depends on the perceived intent of someone else. And this is not only in what we know about life, it's also recognized in the law, for example. And what we need to do in theory and in the law and in life is to draw a distinction between an act of commission and an act of omission, and again, no opportunity to act. And to know what those are, one has to figure out what the status quo, is. Now, what this actually is a stress test of this paper that is Cox-Friedman-Sideri paper we published in Econometrica in 2008, developing a neoclassical approach to studying reciprocity, as opposed to throwing economics out the window and saying we immediately have to go to psychological game theory. Okay. So here's, there's been very little empirical work on the effects of commission, acts of commission versus acts of omission, which can only be talked about relative to the status quo. And we provide direct evidence on this. And a main contribution is a simple design that addresses the central question. And by simple, I mean, I take this as a self-complement, because I think the same principle that's well understood to apply to theory, which is the simpler theoretical model that captures a phenomenon, is always the better one. The principle of parsimony, or what Samuelson in his foundations called Occam's razor, also should apply to experimental design. Okay, now I'm not sure, can that be seen from the back of the room? If not, I can solve the problem. Fine, okay. Okay, so for the moment, just ignore all the labeling in those two figures. Ignore all of it. And then I'll show you one of them blown up, so I'm sure you can see it. Here. Ignore all the labeling in that except where it says player A and player B. There's no labeling, nothing at the top. And so then you'd say, oh, this is a game where the player A can move left or right, and after that, player B can move left or right, depending on which side of the tree we're on. Now, a consequentialist model would say, okay, then we're just going to look at the ordered pairs of payoffs at the end of the final nodes. All right? That's what a consequentialist theoretical model would say. And so we know what the special case of neoclassical preference theory would say, not to be confused with the theory itself. It would say, we know we're going to end up at 15.5, the top number being player A's payoff. Why? Because player A says, I only care about my own payoff. I want 15. And knows that player B has the same preferences. And so player B is certainly not going to punish by moving right, because it's going to cost him money. All right? Homo economicus is never going to punish because it's costly. So we know that that model says all players can end up at 15.5. Okay, well, let's suppose we talk about all these social preferences models, whether inequality aversion, quasi-Maximian, or whatever. Now, they will say, well, depending on the particular model, we can end up at one node or another. All right? But now, let's start to say, okay, but they're going to say that we're going to end up in a particular node regardless of how we got there, because they're purely consequentialist models. All right, now if we go back here and we say, okay, so what we have here are two simple game trees, and the ordered pair here of payoffs, same here, same here, same here, and so on. And so what's the difference between these two games? How you get to these final nodes. Okay. Now, over here, I'm going to look at the left-hand diagram first. Here, the endowments are, the first mover's endowment is 15, and the second mover's endowment is 5. So in order to go down the left side of the tree, it simply matters that the first mover makes no change in the endowments, doesn't alter the status quo. In this case, it means uphold those endowments. Going down the right side means that the first mover needs to give $15 of his own endowment, $5 to the second mover. They're then equalized at 10-10. Okay. This game, the initial endowments are 10 and 10. In order to go down the left side, the first player A has to take $5 from the second mover's endowment, as opposed to going down the right side is you simply uphold it. So what we have here is something where it looks at what's the path, but we're using the difference between the initial endowments and how to construct the same altered endowments that go to the second mover requires different actions of commission or omission that are defined relative to the status quo ante the play. Okay? All right. So this is something where the consequentialist model would say, they would say, there's no difference between these two games. It's simply a framing effect. The alternative theory says, no, these are completely two different games. Okay? All right. So that's what we're doing. Okay. So I've already said this self-regarding preferences says all play ends at 15.5. The social preferences model have different predictions about where you end, but they say it'll be the same in the two games. Okay. What does the alternative revealed altruism theory, how does this construct it? Well, first of all, what it does, it has a partial ordering of opportunity sets. It has a called more generous than. It has a partial ordering of preference orderings called more altruistic than, and it has two axioms that link those two partial orderings. That's the logical construction of the theory. Let's look at the ordering opportunity sets. And here, so the first mover in any of these fairness games actually chooses the opportunity set of the second mover. And so let's let M denote my money payoff. We're going to be talking about my preferences as second mover. Let's let H star denote my maximum payoff in opportunity set H, and YH star denote your maximum money payoff. Then opportunity set G is more generous than opportunity set F to the second mover. Well, if G gives the highest possible payoff in G is higher than it is in F. You took an action that increased my maximum possible payoff. But you say, well, wait a minute. Suppose your action increased my maximum possible payoff by $1, and your action increased your maximum possible payoff by $1 million. Then I'm likely to be unimpressed that your intention was to benefit me, so-called self-serving generosity. Okay, this second line fixes that. All right? This says that if I'm going to think that your intention was to benefit me, is more generous than, thank you, then it has to be the case that my maximum amount increases by not less than yours. Okay.
So Jim, just as a point of clarification, so if I would put together Laura's talk with this, I would say that the experiment, your manipulations are changing the relevant opportunity set for player one.
No.
Because take is so painful.
Here I'm just talking about the ordering. Yeah.
I was careful. I said relevant opportunities. I get that the opportunity set's the same, but
yeah.
The relevant from such a painful act of taking.
Yeah.
You've also curbed player one's relevant opportunities.
I agree, but we're totally focusing here on second mover behavior.
I get that, but
yeah.
It's also the theory should apply for player one.
And you know what? It comes through in what you just said comes through in the data. Yeah. Yes, I agree. Yeah. Okay, so the two opportunities set for player B in both in both treatments, they are the choices on the terminal nodes, but MGTF for player B because I just explained that 10 to 5 is greater than less than that. Okay. Okay. The next part of this is the reciprocity axiom. And it captures formally a very commonsensical idea. If FM provides a more generous opportunity set than SM, then SM's preferences will be more altruistic. You do me a favor, I feel a norm to return the behavior. So you'll be more altruistic if you move one way or the other. Okay, so the original paper tested that extensively. I mean, we had data from 7 different experiments, and 6 of them were previously run by others, so we can't be, accused of designing experiments to confirm a theory. Okay, but what we didn't do is test this business about in the act of commission versus act of omission, what comes from another axiom. And Axiom S simply says that you have a stronger reciprocal reaction to acts of commission than you do to acts of omission, and even a weaker one if there's no opportunity to act. So it brings that formally into the theory. Now, that means that this revealed altruism theory has very sharp predictions. It says that if you look here, it says that in this game, where in order to get over here, it means that the first mover simply upheld the original endowments, then that you're less likely to punish than you are over here, where in order to get over here, the first mover took from you to get over here. Okay? And a similar explanation about what's on the other side of the diagrams. And so what we have here is not a design that can reject all the fixed preferences models in favor of our model. We have something here where the data can reject all of them because ours has some very sharp predictions. What ours model predicts is that you will tend, in the 2 games, you'll get more play at here and there than you would get in the opposite locations. It predicts a precise pattern across the 2 games that has to hold. So the alternatives say you're going to end up in the same place in the 2 games. Ours predicts that you're going to end up in these 2 extremes. Okay. All right. So to test these, the predictions more rewarding than punishment follows an act of commission than an act of omission. The design pins down all of these possible observable outcomes. Now, there are 2 ways of testing these implications of Axiom S, the one that brings in the distinction between omission and commission. We can use all the data, and we do that. We can also do a more nuanced test, because Axiom S actually says if someone is reciprocal, they are more reciprocal when it's an act of commission than an act of omission. So we do it both ways. Okay. Okay. So how do we do this? And see, I've got 5 minutes. I'm going to have to skip over a few things. But we use the strategy method for second movers. Make sure we get a lot of data for them. Double-blind payoffs between subjects design. And then we have actually 3 experiments now. And in experiment 1, the endowments are earned. In experiment 2, they're randomly assigned by the administrator. And in 3, they're also earned. The difference between the 2 ones where they're earned, in one case it has some tournament incentives in it. In the other case, it's an absolute performance. So those are the 3 ways we implemented this. Okay, start to look at some data. And so this is the first experiment. What we see right away here is that we get very different sample proportions across these 2 games. This is the 15-5 game. This is the 10-10 game. They only differ, right, by what the endowments are and what the type of choices are you have to make to get there. And it's this is a p-value. Certainly has some significance. This is a player A. So what do we say about that? Well, these property rights are important to these players. Okay. What about the player Bs? Oh, look at this. Oh, we get big differences here. P-value is 0.061. Supports Axiom S. Now, the next thing is, what if we look at the subgames? What if we look at the data on the 2 different sides of the game tree in the second part of this? And here, where we're talking about no decrease, decrease by 6, no increase, increase by 2. And if we look at that for 2-sided strategies, we get this result. But the main thing is what's really getting a lot of significance is where we go down the right side of those trees. Okay. Now let's say, well, some of the players actually, as in any fairness game, you know, a certain proportion of them will behave like the Homo economicus, economic man, completely selfish. And our Axiom S really says, it says people who are reciprocal are more reciprocal when it's an act of commission than an act of omission. So if we look at those proper subset of the subjects who anywhere in the experiment made at least one choice that was not consistent with economic man preferences, and that's what we're doing here. The reciprocal players B, and then we get, I keep hitting this wrong, but okay. Then we get particularly strong results where it's highly consistent everywhere with the alternative revealed altruism theory, and it's on both sides of the tree. Now, the second experiment, this is where the earned endowments, and in this case, we see right away, looking at the overall results, we're already getting a big difference here. And notice that when we discriminate between earning endowments and not earning endowments, we get a very big difference in first mover behavior. Okay. So this is a warning. We need to be concerned about whether it's house money or not. The question for this paper is, what about player Bs? Does it make a big difference there? And for player Bs, And in this case, of course, it was important we used the strategy method because with this huge change in player A's, we'd had a problem. But in this case, for player B's, look at that. Again, these are p-values. So we get a very, very strong support for this Axiom S coming through with player B's, although it had a big effect, the difference between earned and unearned on the player A choices. Subgames, we get, again, very strong results on the subgames. Again, these are all p-values. Fisher's test for the whole game is 0.004 for the two subgames. Those are, again, p-values. Okay. Restricted to reciprocal player Bs, very, very strong results. Robust support for this Axiom S about intentions. Earning endowments is not necessary to support this conclusion. Okay, so I think I'll just about get it. Okay, so discussion. Subjects with revealed preferences are quite sensitive to acts of commission that overturn the status quo. In revealed altruism theory, our theory, status quo is exogenous. Establishing the status quo is key to the empirical bite of this Axiom S and the intensity of reciprocal reactions towards acts of commission. And I think this may be where we can tie in with your literature. It says two experiments did this with earned and laborious relative performance or randomly. Said a third experiment is in progress. Actually, that's completed now, and we've analyzed the data, it just adds additional support to these conclusions. Questions?
Great, thank you very much. So we have time for one quick question, two maybe.
Hi, Jim. I enjoyed the presentation. I'm curious how you account for the effect of the earned rights within that modeling framework. Where does that fit into the framework?
In the formal theoretical model,
yeah,
does it draw a distinction between unearned property? Formally, it does not. It implicitly, as with all such theories, whether they're fixed social preferences theories or not, they all implicitly assume that what the money you start with is equally important as the money you end with, and they all assume that it's important. So in that sense, this whole body of literature makes no distinction between that. And so when you get results such as the Cherry et al. Well-known paper about behavior being different in a dictator game, and also John List results, based on whether the endowments were earned or assigned by the experimenter, we know that there's that behavioral pattern in there. And so I would say that as more something that's relevant to experimental methods than to theory, because our theory assumes that these amounts of money that are being played with are always important. So in order to want to do that with theory, we would have to say that we think it's an important enough theoretical question to have theories that can discriminate between playing with house money and money that you feel more belongs to you. And like there's no category of theory that does that. I'm not saying that this isn't an important question. It's just something that no one has addressed, because all of our theoretical models are implicitly assuming that you're not playing with house money.
Just a quick comment on this. Theory does distinguish between earned income and transitory income, how it is spent. All consumption theories
Well, a windfall as opposed to, none of these theories in this area does. Certainly it goes way back to Milton Friedman, yeah. Yeah, none of the theories in this area do. Yeah.
Right. So I think this is a great way to take this literature. I'm a big fan of the 2008 paper and these experiments. I want to come back to my question, and it's thinking about player A's. So, you know, the standard model would be player A's don't take because they backward induct, knowing that if they take, the person will hurt them. That would be your standard intuition. Now, if I took the literature on aversion to taking, the fact that I don't go down that branch might be more about I'm not thinking about this in terms of backward induction. Rather, I'm looking at this next node saying, I just don't want to take because I get a severe disutility from taking. And that's where I was going with the question to see, I think the standard model would say you backward induct and you know that the guy's going to hurt you if you take. That's what your theory would be, but it could just be a preference for an aversion to taking. And it would be interesting, you need one more treatment to tell me whether it's backward induction or whether it's simply a preference for not taking.
Okay. But the theory...
And I know that you don't care about that. You're more into player 2, but that's what got me thinking about player 1.
Oh, yeah. No, I fully agree. What we have here is a very, very well-developed theory of player 2. But we've always known that eventually we need to extend it so we have both a player 1 theory and a player 2 theory that fit together. Yeah, but in terms of player 2, they don't really have any reason for caring how player 1 thinks about how they made their decision, but rather all they observe is what that decision was.
Absolutely. So what I'm thinking about now is when you look at those old experiments that Fair did with Rockenbach and that I did with Fair, if you go down a branch that's helpful for player 2 when they know you could have gone down a different branch, then they're kinder to you because you didn't choose that other branch in the first place.
Oh, but that's in
where
here.
I was going.
That's in here.
Right, but you're making an assumption on the structure of my preferences about take or not when you compare those two literatures. That was my only point. We make an assumption that Laura was talking about in my own work and inherently here as well. If you want to test whether it's backward induction or hatred of taking.
But for player 2, there's something.
Absolutely. Here you have that. In the older work, we didn't.
You did.
We did not.
Oh, you did not. Oh, yeah. This theory I'm testing, it has, although it's an extension of neoclassical theory to incorporate a theory of reciprocity and also continue to do it. It also has something that is completely different than this area of approach.
So I'm saying that we didn't have those extra branches.
Unlike revealed altruism theory,
right.
It says what you do can depend on what the first mover didn't do as well as what they did do. They had an option to do something, and they didn't do it. And the way you react can depend on what the thing that they did not choose. And so in that sense, that part of it actually contradicts revealed preference theory.
Right.
Yeah. But yeah, we need to, let's link up with the player 1 stuff. Yeah. Yeah, indeed.